In this video, we're going to demonstrate how to configure Kasm Workspaces autoscaling with Azure. Now, the first thing we need to do is to create an application account in Azure that we can use for authentication.
So the first thing we're going to do is navigate to Microsoft Entra ID and go to App Registrations, and we're going to add a new app registration. We just need to give it a name, so we'll call it eng_autoscale, and we don't need to change the supported account types as we're only going to be using it in a single tenant, and we don't need to set a redirect URI. So we can just register that, and make a note of the application ID, as we will need that for the autoscaling config. And then if we go to certificates and secrets and add a new client secret, we can just give this a description so we know what it's for, and make a note of the expiry date because you will need to rotate the credentials when that expires. You can set it to whatever's suitable for your environment. And now you'll want to make a note of the value here. This is the client secret key or password. We'll need this for the autoscaling. We do not need the secret ID. Kasm Autoscaling doesn't use it. We need the application ID from the previous page, as mentioned. Once you have these credentials, we now need to go and set up the permissions for the application. We can do that under the resource group that we will create for autoscaling. We just need to assign the roles that will give it permissions to create the virtual machines, configure the networking, etc. All of that is covered in detail in our documentation with the specific permissions that you need to set for autoscaling to be able to do its job.
Now that we've got that in place, we can go ahead and log into our Kasm instance. We go to Infrastructure, Pools, and we're going to create a new pool. Let's call it Azure Autoscale, and select the Docker agent type. And then we're going to go to Autoscale configs, create a new Autoscale config. Azure Autoscale. Again, the Docker agent type, select the pool that we just created, the default deployment zone. Downscale backoff is how long we want Kasm to wait once an agent is not being used before it considers destroying it if it's no longer required. We're just going to set it to 60 seconds for the purposes of the demo. Now, the standby cores, GPUs, and memory are the amount of resources that we want the Kasm Autoscale service to keep available at all times for new sessions. For the purpose of this demo, we're just going to set it to 1 core, no GPUs, and a gig of RAM. The override settings allow you to tell Kasm that an agent has more resources than it actually does in order to over-provision it. We are not going to over-provision here. We're just going to say 2 cores and 8 gig of RAM, which will be what we're actually going to give our virtual machine. Now, we need to create a new VM provider. We're going to select Azure, and we're going to name it. Now, at this point, we need to provide a bunch of information from our Azure environment in order to configure autoscaling. So if we go over to Azure, and we can go to our subscription first. So what we need here is the subscription ID. And we also need the name of the resource group. So again, back here, we have our resource group that we have already created for autoscaling. We also need our tenant ID, which we can get from tenant properties. And now we need our client ID and client secret. Now, please note that this is the application ID and not the secret ID. There are 2 separate identifiers for what is essentially the same thing, but it's the application ID that we need to provide here. And then the client secret from the secret that we created associated with the account. We then need to set the Azure authority. Now, in our case, we're using the public cloud, but if you're using Azure government, for example, or China or Germany, select the appropriate one. We need to set our region that we want to create the VMs in. Now, for our purposes here, we're using Sweden Central. We need to set a maximum number of instances. This will cap how many virtual machines Kasm Autoscale can create, regardless of any other restrictions. This is useful just to make sure that you don't scale out of control. We're going to set it to 3 for our demo purposes. Our VM size needs to match the sizing name of the type of VM that you want to create. We're just going to use standard B2MS because it's a nice, easy, cheap resource. But depending on your requirements, you may need to go with a bigger size. Similarly, for the disk type, we're just going to go with the standard LRS because we don't need additional disk performance. And we're just going to give it 100 gig disk space. Obviously, scale this up if you're going to have a lot of workspace images that need a lot of space. Now, the OS image reference can be a challenge to get. The easiest way is using the AZ CLI command tool, which is documented in our Autoscale documentation for Azure. You can just search for the image that you're after. Here we're going to use the Ubuntu Jammy. And so this is the JSON blob that you'll get back from the AZ command line tool that will give the information of the image that you want to use. If it's a Windows image, you need to make sure you tick the image is Windows option. If you're using your own images that you've generated within Azure, very similar process just to get the blob. If you read here, you can see you can also provide it in this format. So if it's your own custom image, you can provide the full path through the subscription to your image name to use it that way instead. For the network security groups and the subnets, again, these need to be the full path name of those objects. So what we're going to do is go back to our virtual machines. This is the server instance that's running. We're going to network settings. And we're going to click on network security group. And we're going to do JSON view. And then we're going to extract the ID from here. Just copy that, paste it in. And then similarly, for the subnet, we're going to go back to here. We're going to click on the subnet again. And you can see the subnet ID here. We can just copy it and paste it in. We're not going to assign a public IP here because we're not going to be connecting to the agents directly, but you can do if you need to. We're not going to set any tags, so we're just going to put in empty braces. We're going to set an OS username. This isn't usually required for Linux hosts because you'll use an SSH public key, but you can do if needed. And obviously for Windows hosts, you need to provide a username and password. So we're just going to put in our SSH public key here. Now, the agent startup script, we're just going to take this directly from our GitHub and paste it in here. And then what we're going to do is scroll up here and we're going to uncomment the Azure private IP section because that's the environment that we're using. We want to use the private IP. For the config override, again, we're not going to set anything here, but it allows you to change the configuration of the virtual machine if needed. And we're going to finish. And this is now set up and enabled. So what we should find, if we go to our Docker agents and wait a few moments, is that Autoscale will begin to spin up agents for us. And so if we just refresh our agents list, we can see we now have an agent that is in a starting state. We have our dynamic agent spinning up here. It's in the Sweden Central area, standard B2MS, and that is now booting. While that's booting, we're going to go ahead and add ourselves a couple of workspaces to test with. So we're going to add a Chrome workspace, and we'll add a Firefox workspace, and we'll add a Slack workspace. So these will now download in the background, and they will then make themselves available on the agent. And if we just have a look at our workspaces, we can see we have the three of them here. But as you can note, the images have not yet been downloaded onto an agent. So we're going to have to wait for those to finish downloading before we can use them. And we'll need to wait for this to change to a running state before we can start sessions on it. Now, this can take 4 or 5 minutes, depending on the spec of the machine and how many images it has to download to make them available. Obviously, if you have a lot of workspaces enabled, then your agent will have to download all of the images for all of those workspaces, and that can delay startup. Okay, so if we just refresh our agent view, we can now see the agent is in a running state. Now, it will still be downloading the images in the background for the workspaces, but that's fine. If we go back here and refresh, see, still waiting for those images to complete downloading. Now, what you can do, if you go to logging, search for image, and you can see pulling Docker image, created image, created image. So these images have been downloaded onto the core agent. This one is pulling. We just need to wait for it to finish downloading. It is dependent on the internet connection is available to the virtual machines that are running the agents. So it can take a while if you have a slow or metered connection. Or if you happen to be in a region that does not have good connectivity to the Docker registry that you're pulling from. So just bear that in mind when you are scaling your agents and when you are planning for what resources to make available as standby. Because if you know you're going to get a sudden rush of users, you're going to want to make sure that you have agents available that don't have to download the images before people can connect to them. So if we put back to our workspaces and refresh, we can see that these are now available for use. So let's fire up a Chrome session. And while we're doing that, we're going to go back here to Docker agents, and we're going to have a look, and we can see we've now got one session running here on the proxy agent, which is the default built-in one. So that's now up and running. And we're going to start another tab, and we're going to load Firefox one. It's in a new tab, so we don't need to keep opening new ones. See, no resources are available to create a requested Kasm, and that's because that image is not yet available on this agent, and we filled up the built-in agent in terms of CPU utilization because this is a low-spec machine. So we just need to wait for this to finish downloading the image, and then we should be able to launch a Firefox session on it. So if we go back here, refresh our page, and we'll launch Firefox session. There we go, that's now running. So if we go back here, refresh the page again, we can see we have one session running on our agent here, one session running on the built-in agent. And again, we're using the maximum CPU usage because this is a small-sized agent that doesn't have capacity to run multiple sessions. Now, what this will mean is that Autoscale will now see that all of this resource is used up. And we have said that we want to make sure there's always 1 core and 1 gig of RAM available. So this will then start to spin up a new agent to provide additional capacity as we've requested. And if we refresh our agent list, we can see here's our new agent starting up. And if we go back here and refresh, we can see we've now got 2 agents that are spinning up and running. Now, this is fine for us. We're going to get rid of these sessions now because we don't need them for the purposes of demo. So we'll delete them both. Close those tabs. If we go back in here and refresh, we'll see there are no sessions currently running, and this agent is now in a starting state. Now, as we discussed before, we set the downscale back off to 60 seconds. What that means is this will now wait 60 seconds, and it will then evaluate, are there enough agents available to provide the standby resources that we asked for? And if so, it will look to see if it can get rid of any of the unnecessary ones. Now, it will not consider this agent until it's in a running state. So for now, it will be quite happy because we have one agent meeting the requirements, and the built-in agent here does not apply because it is not part of the Autoscale pool that we configured. So we'll always have this agent sitting here, and then we should have one remaining Autoscale agent that meets our 1 core and 1 gig of RAM standby available. So we'll just wait for this one to finish spinning up, and then we can see Autoscale take its decisions. And if we refresh, we now see we have a second agent that is up and running. So at this point, we now have 2 agents, which is more than we need. So once Autoscale recognizes that we have additional resources, it will look to downscale one of these agents so that we're not wasting resources running VMs we don't need. And indeed, if we refresh our agent list, we can see this agent is now in a destroying state. If we go back here, you can see it's still running. It takes a little while for Azure to deprovision the virtual machine, has to shut it down and then delete it. And this will get us back down to our one agent that meets our standby requirements. So if we refresh our list, we can see we're now down to 2 machines. Go back here and refresh, we can see we just got the one agent. So now I'm just going to quickly show you how to completely deconfigure autoscaling if you want to get rid of a pool. So we need to go into pools, we go to Autoscale configs, and we edit the config. And we set the downscale back off to 0, the standby cores, GPUs, and memory to 0. And what this does is it will allow the Autoscale service to deprovision that last agent that we had. And that will allow us to cleanly remove the config and take all of the virtual machines out of circulation within Azure. So we can see this is now in a destroying state. So we just need to wait a few moments while it cleans up the VM in Azure, and then we can remove the config from Kasm. Let's check in. Agent is gone. We just go back here and refresh. Agent is gone. And we can now go into here, VM provider configs, delete, Autoscale configs, delete, and finally pool and delete. And we're back to where we started.
Now we're going to cover how to configure Windows autoscaling within Azure backend. Now I'm not going to go into the specifics of creating the Windows template in Azure. We cover that in our documentation, but essentially you need to create a Windows template, generalize it, and add it to an Azure image gallery so that it can be pulled in by Kasm to provision new virtual machines. So very similar to the Docker agent, what we're going to do is go to pools, and we're going to create a new pool. I'm going to call it Azure Windows pool. And we're going to select the server type. And then we're going to go to Autoscale configs, and we're going to do Azure Windows config. And again, we're going to select the server type, the pool we just created, the default deployment zone, our downscale backoff, which again is how long Kasm will wait before it starts downscaling machines that aren't required. We're going to enable the require server check-in and Kasm desktop service installed. What this means is that the Windows VM will need to have the Kasm desktop service installed, and it will need to report back into Kasm before Kasm will consider it ready and allow connections to it. We're going to do RDP connection because it's Windows, port 3389. We're just going to use static credentials. There are other options. Dynamic user accounts will cause Kasm to automatically create local users on the Windows VM to match the Kasm user that's connected. And you also have SSO options for SAML, OpenID, or with Smart Card, or AD integration if that's what you need. Now, because we're doing static credentials here, we're just going to use the default connection for the account. We don't need any additional connection information. We're not creating an AD record. Reusable under normal circumstances when a session is finished on a Windows server, or all of the sessions are finished on a Windows server, it will deprovision the host and then provision a new one. If you want it to be reusable, because for example you're using something like a RemoteApp or something else that doesn't persist data, users that aren't installing applications, etc., you can make it reusable. The minimum available sessions, very similar to the Docker agent, this is the minimum number of Windows servers that Kasm will keep provisioned available for users to connect to. We're just going to set it to 1 for our demo. Max simultaneous sessions, this is the maximum number of sessions that can run on a server regardless of the number of users. So if we set that to 5, that can be 5 sessions from 1 user or 1 session from 5 users. However, because we're using static credentials here, we are limited to 1 maximum simultaneous user on the server. That's locked. If you were using SSO or dynamic local SSO, you can set this up to higher and have 2, 3, 5, 10 users running on a Windows VM if you want to. We're now going to create a new Azure connection. We'll call it Windows Azure config. Now we need to fill in quite a lot of information here. So all of this can be found in Azure. So we've got the subscription ID. We have our resource group, which you will need to pre-create, which is for your autoscaling. Your tenant ID. Now tenant ID, you can just we'll go over to Azure here. If you just search for tenant and go to tenant properties, the tenant ID is here. You can just copy it out. So we'll do that. Now, the client ID and client secret, you need to create an application and get the client ID and the secret. This is the account ID, not the secret ID. For some reason, Azure has 2 separate IDs and you need the actual account ID, not the secret ID. We're doing Azure Public Cloud, but obviously you've got other options here if you're using a different area of Azure. For our region, we're going to do it in Sweden Central, but you know, pick wherever you're going to do them. Maximum instances, this will limit the maximum number of Windows instances regardless of any other settings, so we're just going to limit it to 3 for our testing. The size is the shape or configuration of VM that you want to use. We're going to use the standard D2S v3. We don't need anything super powerful. Similarly, we're just going to go with the premium LRS disk for this. The OS disk size must be at least the size of the template disk, otherwise it will fail to provision. So our OS disk, I believe, is on the template 120 gigs, so we're just going to go with 128, give us a little bit of headroom. Now this OS image reference, in order to get this, we need to go to the Azure Compute Galleries, Autoscale, we've got our definitions and our versions. Got our latest version, which is this one here. Go to the JSON view, and you've got the resource ID up here. And we can copy that in. And this needs to go into a slight JSON blob. So it needs to be like this. So just ID, and then that subscriptions image path that we just copied out of Azure. You need to make sure you tick the images Windows. And then we need network security group and subnet. So these again are a little bit fiddly to get because Azure. So we're going to go back to virtual machine. We've got our Kasm Autoscale server here, which is the server that's running it. We go to network settings, and we can see we've got our network security group that it's attached to. So we can click into that. Again, JSON view, copy the resource ID out of here, and paste it in. And then for the subnet, if we just go back to the network settings, we go to the subnet, and we go to the default here. Again, subnet ID, we can just copy it out and paste it in. We're not going to assign a public IP to this because we're only going to be connecting directly to it through Kasm. We're not going to supply any additional tags here. You can do, if you're not supplying any, you just need to do a blank empty JSON collection. For the username, this is for connecting to run the startup script. So again, we're going to use the same user as we're using for the static credentials here. And we need an SSH public key. And we need our agent startup script. We are just using the startup script from our GitHub. We have example scripts there, so we're just going to paste that in. We don't need to change anything about it. It's already in place to do what we need. Now for the config override, we do need to put in some configuration for secure boot because we're using a Windows image that has secure boot enabled. This is covered in our documentation, but essentially it's a security profile that enables secure boot, enables the VTPM and trusted launch. If you don't provide this information and your image template uses secure boot and trusted launch, it will fail to provision the VM. Okay, so we've now got our Windows Azure config, and now we just need to wait for Kasm to start spinning up the VMs in Azure. Now refresh the page, you can see we have a Windows server here that is starting, and it will remain in the starting state until it boots in Azure, it installs the Windows service, and that reports back in to our server. So we just need to give it a few minutes for it to do that. If we go back over to Azure and just refresh our view here, we can see we've got our Kasm dynamic agent, which is currently in a running state, and we're just waiting for that to finish booting. This can take 3 to 5 minutes depending on the spec of the machine and how quickly Azure provisions it. But in this case, we're good. It's already running. So we now have a Windows instance that we can connect to. So what we're going to do is go to Workspaces, and we're going to add a workspace. We're going to select the pool type, and we're going to call it Windows Server. Same for the description. We're going to select the Azure Windows pool. We're going to select the web native RDP client. Now you can do things like configure the persistent profile if you want a persistent profile. There's other options here for session time limits, etc. We don't need any of that right now, so we're just going to leave that as it is. We're also just going to create a second workspace at the moment, and we're going to do again pool. We're going to call it Microsoft Excel. And this time we're going to enable RemoteApp. We're going to select the web native client again, and we're just going to do this. So this has already been configured on the template to have a RemoteApp called Microsoft Excel that points to the Excel executable. And again, we don't need to change any of these other bits right now. So what we can now do is go over to our workspaces over here, and we can click on our server, and we can launch session. This will now log us in and give us a remote desktop session to the Windows VM in our browser. Now, along with anything else, if you're joining to an AD domain, then obviously you can use group policy to configure this. If you're not joining it to a domain, then you can make configuration changes on the template to support whatever configuration you want, or you can add those configuration settings into the startup script to make those changes when it boots the VM, depending on what changes you need and whether you can do them before or after you generalize, because with Azure, you have to sysprep the VM template. You cannot leave it as is. So there are some settings that will get reset as part of the sysprep process. So if we go back to our Kasm here and look at the servers, we can see we've now got 2 servers. The second one has started to be spun up because this one is running a session, and we said we always want one available. So while that's spinning up, we're going to go ahead and we're going to kill the session because we don't need it anymore. Now, as we didn't mark it as reusable, when we terminate this session, it will delete the VM as well. So we'll do that. We'll go back here, refresh again. We can now see it's in a delete pending state, which will shortly turn to destroying, and that will deprovision the VM in Azure. So we just need to wait for that to get deleted and for this one to finish starting. So a quick refresh, we can see this one's now in a destroying state. If we go back here, we can see we've got the 2 VMs, and this second one is now in a running state, which means we'll be able to connect to it for a session. And we'll just leave Azure to finish shutting down and deprovisioning that old one. So if we go over here again, and this time we're going to launch Microsoft Excel, we'll do it in the same tab. We don't need a new tab for this. And here we go. We have Excel running in a browser as a remote app. Now, obviously, you can provision the machines with slightly higher spec than we have done. You know, if you're going to have multiple users connecting simultaneous sessions, you'll want to make sure that there's plenty of leeway there for additional capacity. But for our demo purposes, the small machines work just fine. So again, if we now go and remove the session, it will also delete the virtual machine once it's finished because it will no longer need it. So if we just do a quick refresh in here, we can see it's already starting another VM to get us back up to our one available, and this one is in a delete pending state. So we'll just quickly run through, much with the Docker agent deployments, how to deprovision the Windows Autoscaling. It's very similar. So what we do is we go into our Autoscale config, and we scroll all the way to the bottom here, and we change the minimum available sessions to 0, so that Kasm doesn't need to have any provisioned at any time. And we're going to change the downscale back off to 0, just so that Kasm doesn't wait before it starts deprovisioning. And then we're going to finish. Now, that means that the Autoscale pool will now start to deprovision down to 0, but won't until this finishes starting and checks in. Then it can destroy it. So we'll just leave it to run while it's doing that, and we'll go back over here. We can see we've still got the 2 agents running, the other one being destroyed. We can see now the other one's been destroyed. We've just got the 1 in a running state. We do a quick refresh in Azure. See we're down to 2 again. Just the server and 1 agent. And we can now see this is in a destroying state, as it doesn't need to have any provisioned unless a user attempts to connect a new session, at which case it will provision on demand. We just need to wait a few minutes for Azure to finish destroying the VM. Let's refresh again. We can see now no servers. And if we go back into Azure and refresh, all we have is our Kasm instance. So now once we've done this, we can safely go in and we can delete our VM provider. We can delete our Autoscale config. And finally, we can delete our pool. And we're back to where we started.